we are going to talk about your favorite subject. And your favorite subject is X-bar theory. X-bar theory is one of the fundamental things you need to know about when you're studying syntax. Everybody knows it. If you want to come to graduate school 5 years ago, you would have need to know it. I don't know if they ask you that anymore. So, what is it and what's the point of it? I think we talked about this same slide last time, but we'll review it. X-bar theory is a generalized way of doing phrase structure that makes some generalizations that phrase structure rules are, the traditional kind of phrase structure rules we're not able to do, in particular by using variables, right? That's one of the major components of X-bar theory. The reason that it's called X-bar theory, by the way, okay, X is of course a variable that will stand for some category. Variables are like these things you learned in your math class when you studied algebra, right? They are placeholders that can have, in principle, any value assigned to them and can be used to make more general statements than you would be able to make if you didn't have them at your disposal. I don't know if I told you this already, but this guy here in mathematics is usually called prime, right? So if you were to read this in a math class, it would be read X prime. The reason it's called X-bar theory is that back in the old days, the first formulations of an X-bar looked like that. So you had an XP up at the top, say, and an X for a head, and then the intermediate level of representation looked like this. And this thing at the top of the X is indeed called a bar. People soon discovered that most people's typewriters don't have that symbol on it, so they had a difficult time writing it, so instead they just used this one, and hence the term X-bar theory instead of X-prime theory, even though nobody uses the bar anymore. So that's how it got its name. But the important thing is the X, and X is a variable that can be used to make generalizations about phrase structure patterns. And in the place of the old style rules where we always had to name categories and the various character of the categories and elements that phrases consisted of. So by using variables, you can eliminate redundancy that is noticeable in the ways of old. So the old ways of doing phrase structure rules that we studied last semester and that we talked about in the last few weeks have some statements that are essentially being made over and over again. And by using X-bar theory, you can eliminate the need to make the same statement over and over again. So to be redundant means you say the same thing more than you have to. In addition to this, we can make some predictions and account for some data that we were simply not able to account for using traditional phrase structure rules, especially due to the fact that we identify types of constituents and elements in a phrase that are classes that are distinct from categories themselves. In particular, we've identified 4 kinds of things inside a phrase: a head, a complement, an adjunct, and a specifier. We've been a bit vague about what a specifier is, though we'll talk about that at length in the future. A head, though, is a very important element of a phrase. It is the unique atomic element that assigns its category to a phrase. So every NP will have exactly one N. that assigns its category orientation to the phrase itself. And heads behave in a particular way that allow us to identify them as heads that are distinct from other elements in a phrase, like complements. We identified the behavior of complements as well and distinguished that behavior from the behavior of other elements inside a phrase, like adjuncts, and we talked about how they are different. Adjuncts and complements, in principle anyway, can be any kind of phrase. So complement and adjunct are not a syntactic category, but another type of classification that we utilize in the formulation of XBAR rules that allows us to do some wonderful things that we weren't able to do when we restricted ourselves to the discussion of categories per se. In addition, these XBAR rules allow us to make falsifiable predictions about linguistic universals that old phrase structure rules do not allow us to do, to make. So those are the things you should remember about XBAR theory. And of course, you should remember what the rules are. The rules that we formulated are a bit less universal than we would like. We're going to fix that soon, but for now, we'll say that these work for English. An XP has at most two daughters. One is always an XBAR, and the other, if present, goes to the left of XBAR, and that's a specifier. Every X is the daughter of an XBAR, and if there is a complement of the phrase in a phrase, it is the rightward sister of the head. So X is the daughter of XBAR, and perhaps the sister of a complement. Wherever there is an adjunct, it is always the daughter of an XBAR and the sister of a distinct XBAR. And adjuncts, we said, can go, according to our rules, to the left of an XBAR or to the right of an XBAR, which means that they can appear to the left of a head or to the right of a head. This was necessary for the simple fact that we define adjuncts on either side of heads. So for example, adjectives that modify nouns are adjuncts that go to the left of a head. Prepositional phrases that modify verbs or nouns go to the right of the head. So adjuncts can be either the left sister or the right sister, but they are always the sister of an XBAR and the daughter of some other XBAR. We will change these rules a little bit in the future, but not much. So you're going to remember these and use them when you draw the trees. So the first nice thing to notice is that by formulating these three rules in the way that we have, you eliminate the necessity of stating basically the same thing over and over again. In our old rules for VP, NP, PP, and AP, for example, we said a VP consists of, okay, a bunch of stuff in the midst of which is exactly one atomic V. An NP consists of various stuff, optional stuff, and exactly one N. A PP consists of stuff, but especially exactly one P, and the same is true for APs. These are not exactly the rules that we formulated, but it doesn't make any difference. The point is, there's just something being repeated here 4 times that you could have just said with one rule, right? Or in our case, 2 rules. I mean, the rule or the generalization that I'm talking about is that every phrase has a head. These rules don't actually say anything about what a head is. And the fact that we stated that VPs consist of blah, 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 followed by a V, followed by blah, 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 is just, it's an accident. I mean, we could have formulated anything we wanted to. This type of complex here, stating that an XP is the mother of an XBAR, and that X is the daughter of an XBAR, allows us to state in the simplest terms possible that every XP will have exactly one X bar. And whatever category X is, that's the category that XP will be by virtue of the fact that we are using variables. And when you define a variable, it has to keep that value. So if you say X equals X in mathematics, the reason that this statement is true is because if X is 4, if the first X is 4, then the one after that has to be 4 too. You can't shift the value of a variable. So if this is an N, then this will be an NP. If it's a P, it will be a PP, and so on. So now we can predict that every phrase has a head. And in this way, say a bit about what a head is, right? It's the element in a phrase that will give its category orientation to the phrase itself. So you should be able to answer the following question. True or false, X-bar theory is better than traditional phrase structure rules? Well, that part we know is true. Is it better than traditional phrase structure rules because the rules of X-bar theory distinguish complements from adjuncts, and phrase structure rule or traditional phrase structure rules don't? I hope you know the answer to this question. Ophelia, what's the answer to this question? Oh, I hope it's true. Of course it's true. Right? That was one of the major motivations for what we're doing, and the complement adjunct distinction is quite important. So, what's the difference between a complement and an adjunct? Well, there are a few differences in terms of the behavior of those elements, but and this behavior can be accounted for by stating the rules the way we have done. Complements are the sisters of heads and the daughters of X bars, whereas adjuncts are the daughters of X bars and the sisters of other X bars. So our specifier rule tells us that a specifier is the daughter of XP and the sister of X bar. The adjunct rule tells us that any adjunct will be the daughter of an X bar and the sister of an X bar. And our complement rule tells us that complements are daughters of X bar and sisters of heads. So in a phrase that had one complement and one adjunct and one specifier, there would be, of course, an XP and a head. In addition, there would be two X bars in the phrase. For every adjunct in a phrase, you need to add an X bar. Thus, if there are, and there's always going to be at least one because you need a mother to the head. So every phrase will have at least one X bar. And the number of X bars, the total number of X bars in a phrase, will be equal to the number of adjuncts in the phrase plus one. So here we have an adjunct, so there's two X bars. One adjunct, two X bars. Specifier and complement do not require additional X bars. The complement is the daughter of the one that's the mother of the head, so that one's always going to be there. And the specifier is the daughter of XP. So, specifier rule tells you where to put specifiers. Again, specifiers are daughters of XP, sisters of X bar. Complements are daughters of X bar and sisters of X. And adjuncts are daughters of X bar and sisters of X bar. So in a phrase like the glass of wine on the table, we said we'll call these, like the specifiers, so it will be the daughter of an NP and the sister of an N bar. Obviously glass is the head of the phrase, so it's going to be the X or the N in this case. The difference between on the table and of wine is interesting. They're both prepositional phrases, so they're phrases of the same category, but they behave rather differently. In particular, of wine is a complement, and on the table is an adjunct. Therefore, we draw a tree that represents them in this way. Adjuncts are the sisters of X bar, sisters of X bar and daughters of X bar. Complements are the daughters of X bar, but are sisters to heads. How do I know that of wine is a complement, not an adjunct? Ruby, I see you now. You should be sorry. How do I know that, what did I say? I can't remember. Of wine. How do we know that of wine is a complement and not an adjunct? What do you mean? Like what? Okay, good, right? If you try to, despite the fact that these two phrases have the same syntactic category, if you try to switch their order, it won't work. So a glass on the table of wine is terrible. It's not grammatical. And the reason for that is that of wine is a complement. And complements do not like to be separated from their heads. So if you try to put some other adjunct material in between a head and its complement, it will make the phrase ungrammatical. And that's how you tell whether something is a complement or an adjunct. Notice, or maybe I should make you do this. I'll just ask you, if I want to draw a tree for the phrase, the glass on the table, like, let's pretend this is a glass. Let's pretend this is a table. This is a bad game. Let's just say there's a glass on the table, and the glass is on the table. Can you draw a tree for this? Or what would I have to change about this tree for a phrase, the glass on the table? What do I have to do to this tree? Do you think this is a hard question? That's not going to be. It's an easy question. Lily, what do I have to do to my tree? Tina, what do I have to do to my tree if I want to just say the glass on the table? What? Okay. Anything else? No. Okay, good. So if I just want to take the wine out, then you just remove the phrase. Under no circumstances should you even think about taking away one of the end bars. So if you drew a tree like this, what's wrong with this tree, Tina? Why? There is an end bar.
Because there is an adjunct, so you have to draw two bars.
Okay, good. Right. So the problem with this tree is I know on the table is an adjunct. How do I know? I can play with this example. I can say, you know, the glass of wine on the table, the glass from Ruby on the table, the glass of mine on the table. I can put things in between this head and this phrase without affecting the grammaticality of the example. So that proves that this PP is an adjunct. But the tree says it's a complement, because this is the daughter of an X bar and the sister of a head, which means I drew something as a complement. I represented it as a complement, but it's not a complement, it's an adjunct. So, as we already said, for every adjunct you have in a tree, there's going to be an extra X bar. So the number of X bars in a tree will equal the number of adjuncts plus 1. How many adjuncts are there in the phrase, the glass on the table? Answer, 1. How many X bars, how many N bars do you need? Answer, you need 2. Because this is not a complement. So don't draw it as a complement. So, as we said, the only thing you need to fix about this example is just take out the complement. Complements are optional. Now, I know that that's not universally true. We will see plenty of examples where you actually need to have a complement in a phrase. For example, with transitive verbs or certain other lexical items that need complements. But our rules say that, complements are not necessary. We'll fix the problems with that later on. But the only thing absolutely necessary in a tree now is the head, at least one X bar, and of course the XP, the phrase itself. So if you want to represent a phrase without a complement, no problem, just take it out. But this X bar is still going to be the mother of the head, and not going to be the mother of an adjunct. Right? Adjuncts are not sisters to heads, can't be. So, if you have an adjunct like the glass on the table, you still need 2 N bars. And this N bar, who is the mother of the head, is just the mother of a head that doesn't have a sister. So if it had a sister, it would be a complement. But complements are the only things that can be sisters to heads. Okay, good. So, this is your, for now we say these are specifiers. Adjuncts are daughters of X bar and sisters of X bar, always. That will not change. If there's a complement, it will be the sister to the head. And of course, N is the head of this phrase. It is the thing, the atomic element that gives its category orientation to the phrase itself. And by making this distinction between, especially between heads and complements, we can account for data that traditional phrase structure rules did not allow us to account for.
So students is a well-formed noun phrase. Students of English is a well-formed noun phrase. Students of English from, students from Providence University is a well-formed noun phrase. Students of English from Providence University is a well-formed noun phrase. Students from Providence University of English is a terribly badly formed noun phrase. And please remember that when we have, in syntax and phonology anyway, where you have an asterisk before the example, it indicates that that example is ungrammatical. So, students from Providence University of English is ungrammatical, but students of English from Providence University is grammatical. So, E is bad, D is good. The rule that we had for NPs was, look, complicated, but we can generate D and E with this simple rule that says that an NP consists of an N followed by maybe some prepositional phrases. This rule will generate A, B, C, D, E. All of them. We want to rule out E though. We want to say, we want a rule that doesn't generate E, but that does generate A through D. Well, good luck with that if you only allow yourself to refer to the category orientation of the constituents in a phrase. There's nothing you could do to this rule that would make it generate D but not generate E. because of English and from Evidence University are both prepositional phrases. So, according to this phrase structure rule, there's no way for him to account for the difference between D and E because this phrase structure rule doesn't say anything about adjuncts or complements. Adjuncts and complements are not a syntactic category, so this rule can't do anything. This rule, these two rules, can do something, right? Exactly because, look, adjunct and complement are mentioned explicitly in the rule. And this rule demands that where there is a complement, it is the sister of the head. On the other hand, adjuncts are not sisters to heads. This would explain why the phrase of English cannot be separated from the head. You can't leave your sister. So, because these two rules make a distinction between complements and adjuncts and demand that a complement is never separated from the head, you can easily account for the distinction between D and E. D has a case where the complement follows the head, is adjacent to the head. E doesn't. You can draw a tree for D. You can't draw a tree for E. So, the blue ones here are complements. The pink ones are adjuncts. The noun students is, of course, the head of the phrase. Anytime you have a complement that's separated from its head, you're going to get ungrammaticality, and now our rules predict this, so it's wonderful. Is it true or false? Be prepared to defend your answer. That X-bar theory is better than traditional phrase structural rules because traditional phrase structural rules do not make scientific predictions about human languages in general, and the rules of X-bar theory do. Winnie, what do you say? Do you understand the question? Oh my goodness, why not? Okay, X-bar theory rules are better than traditional phrase structure rules in a number of ways. That much you know. Do traditional phrase structure rules make predictions about human languages in general?
So when I said, for example, our old NP rule, let's say, was this, I think, right? Does this rule make any predictions about human language in general? It does. What does it predict about human languages in general? Would you like to change your answer? Ophelia Helper, does this rule say anything about human languages in general? Remember, this was an NP rule for English, right? Right? Okay. What does our NP rule for English say about the nature of human language? Did you say nothing? That's right. This is an NP rule for English. If we want one for French, we need a new rule. Right? If we want one for Chinese, we got to make a different rule. And you could put anything you wanted to in a rule like this. You could just say this, or this, or this. And the funny thing is, not that funny, the interesting thing is, we never find any languages in the world that have noun phrases that don't have nouns. No language that we've ever discovered is such that a noun phrase consists of a determiner followed by a verb. Now that might seem totally obvious to you, but there's nothing that would prevent us from describing a language like that with these traditional phrase structures. On the other hand, if you, so this thing is true, right? If you make the proposed that every XP has at least one daughter, X bar, and every X is the daughter of an X bar. You said something, oh my goodness, I'm sorry. You said something about the nature of phrases in general by using this variable. Remember, this X, this X, this X, and this X all have to have the same value. So just like when I have an equation, like this in algebra, right? The reason this statement is true is because this X and that X are the same thing. Right? Whatever value you assign to this one, the same value as this one, and this Y, these two Y's have the same value. That's the nature of a variable. Right? These two rules together tell you that every phrase has a head. Every NP will have exactly one X. Every VP will have exactly one V. This is a way of describing exactly what a head is. It's the atomic element inside a phrase that gives its category orientation to the phrase. Our old NP rule, AP rule, VP rule, and so on, didn't have anything that predicted that phrases have heads. We just sort of spelled it out one rule at a time and treated it as if it was some kind of accident. We reminded ourselves of this rule of thumb for drawing trees, that every VP better have exactly one V and every PP better have exactly one P, but we acted like this is some kind of a coincidence or something. These two rules conspire to predict every phrase will indeed have exactly one head. And that's actually a generalization that we can extend to languages in general. So we don't have to formulate new rules every time we study a different language. We can use this template of rules to describe languages in general. And indeed, when it comes to describing the nature of language and the learnability of human languages, the presumption is that something like these rules are contained in the language organ or language faculty, so that when children are born, they are born with the rules of X-bar theory right up there. They don't have to learn them. They just have to fill in the blanks with whatever lexical elements and various other nuances of their particular language and the behavior of adjuncts and complements, which side of the head these things occur on, and so on. Things that we'll talk about later on. But these general phrase structure rules, which tell you that every phrase will have a head, complements are the sisters of head, heads, adjuncts are sisters of X bar, and daughters of X bar, we can assume that children actually have that right from the beginning. And that's the reason why all languages are describable by these general rules. We predict that this is the case. We predict that it's a universal property of languages that complements our systems of heads, and that every phrase has a head. We can keep testing that prediction. If it turns out that there are counterexamples, we can think about them, but it is a prediction, right? Falsifiable predictions are good things in science. Not making any is bad news. And that's one of the reasons why traditional phrase structure rules are leave a lot to be desired. Right? Phrase structure rules like the ones we studied last year are good for some things, for representing constituency and so on. But when it comes to making predictions about the nature of language in general, they really don't say anything at all. Okay? So that's why the answer to this question is true. And I just said this, but X-bar rules capture linguistic universals that phrase structure rules don't capture. Remember, a linguistic universal is some property that all languages have. So a rule like this one over here, a noun phrase consists of maybe a prepositional phrase followed by exactly an adjective followed by 0 or more verb phrases. This is a perfectly well-formed phrase structure rule. And as I said last time, the fact that we never, as I said a moment ago, the fact that we never proposed a rule that looked exactly like this is, well, just an accident. We're treating it like an accident that there are no languages that have noun phrases that look like this. These X-bar theory rules don't do that. These X-bar theory rules predict that the fact that every noun phrase has a noun is no accident. The fact that every prepositional phrase has a preposition as a head is not just a coincidence. Right? There are scientific falsifiable predictions, right, made by these rules. One of which is that every phrase has a head. Another of which is that complements are the sisters of heads, and so on. We geared these toward English because we've been talking about examples in English, but we'll see very soon how we can generalize these rules just a little bit more and assume that they are in operation for any language that we run into. Okay? So, true or false, hey, X-bar theory is better than traditional phrase structure rules because traditional phrase structure rules do not allow us to account for certain types of anaphora. And the rules of X-bar theory do. Oh, and tell me what anaphora is. You better not say you don't have any idea. Ruby, give him an idea. What does this word mean? I'll have to wake up and tell me what this word means. I'm going to tell everybody what this word means. Tell these Taiwanese people what this word means. Give me an example. Okay, good. Right? An anaphor, at least in the broad sense, is a word that refers back to some other word or phrase. So pronouns, reflexive pronouns, other words that substitute for a phrase, for another phrase. Is this true or false in that? You say false? X-bar theory is better than traditional phrase structure rules because traditional phrase structure rules do not allow us to account for certain types of anaphora, and the rules of X-bar theory do.
It's definitely true. What am I talking about? Okay, the example that we gave earlier is the phenomenon of these one anaphora. So, a big box of candy, if we follow our traditional phrase structure rules, the ones we don't like anymore, we get an NP that has 4 daughters. It consists of a D followed by an AP followed by an N followed by a PP, and if we apply some other rules like the AP rule and the PP rule, we can fill in the rest of the tree. So it looks like this. Last year, if you wanted to draw a tree for a big box of candy, you'd have to draw a tree like this. Remember? Good. So what's the matter? I want a big box of candy, not a small one. Okay, this word is an example of an anaphoric expression. What does it mean? What does one mean? If I say, I want a big box of candy, not a small one, what does one mean? Daphne, what does one mean? It means candy? What does it mean, box of candy? Well, hurry. What does one mean? I want a big box of candy, not a small one. Box of candy. So, if I didn't want to use anaphoric expressions, I would say I want a big box of candy, not a small box of candy, right? I think that's what it means. That's what I mean when I say it. I want a big box of candy, not a small one. So, if a string of words can be replaced by an anaphoric expression, then that string of words must be a constituent. It must be a phrase. Now the question is, which phrase is it? Which phrase is this anaphoric expression replacing? And the answer is, you're going to have a problem because there isn't a phrase, right? Box of candy is not a phrase. A big box of candy is a phrase. Big is a phrase. Of candy is a phrase. Candy is a phrase. But box of candy is not a phrase in this tree. It's not a constituent. A constituent is defined as a set of nodes that is exhaustively dominated by a single node. Box of candy is not exhaustively dominated. This is the mother, but she exhaustively dominates this entire set of nodes. Right? 1, 2, 3, 4 daughters. So that's a constituent. It's an NP, of course. But that's not what this word is going proxy for. It's not what it's substituting. We want to say what kind of phrase is box of candy. We want this thing to be a constituent in the tree, but it's not. So this here is not a constituent, but the word one is replacing that string of words, which causes a problem for us. So we know it's a constituent because it's passing constituency tests, but it's not represented as a constituent in our tree. So X-bar theory to the rescue. Now we can draw a tree for a big box of candy. What kind of a constituent is box of candy? Answer is an N-bar. This mother dominates only box and of candy, which means that box of candy is a set of nodes that is exhaustively dominated by a single node, which means it's a constituent. It's a particular kind of constituent. It's not an NP constituent, it's an N-bar. But that's good, because at least we have a way of saying what it is that this anaphoric expression does. It substitutes for N-bars. So, the original question was, true or false, is X-bar theory better than traditional traditional phrase structure rules because X bar theory allows us to account for the behavior of particular types of anaphoric expressions? Answer, yeah, true, right? Like, especially this one, and some others. So we saw the examples of expressions like do, like John sings opera in the shower, but Mary rarely does. Right? This is going proxy not for N bars, but for V bars. We've even got anaphoric expressions that can substitute for A bars and so on. So this is yet another advantage. Now, true or false, X bar theory is better than traditional phrase structure rules because traditional phrase structure rules do not allow us to express which phrases modify which other phrases. For example, in a sentence like, Bill hit a man with a stick. Is this true or false, Ivy? There's two Ivies. Gina, is it true or false? Jane, is it true or false? Oh, are you sure? Is she right, Ivy? Ruby, is it true or false? Why? Okay, good, thank you. I'm glad. Most people get that wrong, right? Look, there's a lot of great things about X bar theory, and there's a lot of unfortunate things about traditional phrase structure rules. But if you said that traditional phrase structure rules do not allow us to express which phrases modify which other phrases, like in a sentence, Bill hit a man with a stick, of course that's wrong. That's what phrase structure rules were for, right? The reason we started with these trees is to represent what constituents were and what constituents modified which other constituents and so on. So that was not the problem. That was what it was good for. X bar theory can do that too, but traditional phrase structure rules didn't have a problem with that. It was very explicit. So we were able to draw a VP tree like hit a man with a stick, and distinguish it from a VP like hit a man with a stick, right? So the difference between this tree and this tree is that in this tree we've got, okay, there's a man, he has a stick, and somebody hit him, right? So this is hitting a man with a stick, right? See, there's his stick, and there's the guy who's hitting him, whatever it is, kangaroo or something. Hitting somebody with a stick is different, right? Is using a stick to hit someone, right? Phrase structure rules, the traditional phrase structure rules didn't have a problem doing that. That was pretty much the whole point. So, yeah, the answer to that last question was false. You can certainly turn these into X bar trees, no problem. We'll talk about that when we get back. Okay, enjoy your break. Okay, so, as mentioned, representing modification relations in a tree, in other words, representing which phrase modifies which other phrase, is something that we were certainly able to do with the old style phrase structure rules. But we can do them with X bar theory too. It's very easy. In a situation where you want draw a tree for VP, hit a man with a stick, meaning using a stick to hit a man, you just follow the old rules. Make sure that the adjunct is part of the VP, not part of the NP, and make sure it's an adjunct. Right? So if I have a phrase like hit a man with a stick, a man is a complement. Objects of verbs and prepositions behave like complements. So you can hit a man with a stick, but you can't hit with a stick a man. And the reason for that is because you can't separate a complement from its head. It will affect the grammaticality of the phrase. You've seen that happen many times. Okay, behaves like a complement, treat it like a complement, draw it like a complement. A complement is the sister of the head and the daughter of an X bar, in this case a V bar. So daughter of X bar, sister of X, or daughter of V bar, sister of V. The complement of the verb is the sister of the verb. A man is an NP, of course. We treat determiners as specifiers for now. The head, of course, is man. What else would it be? And every NP has to have at least one N bar because N's are the daughters of N bar, not the daughters of NP. And with a stick is a complement of this verb. It modifies the VP, but it's not a complement. I hope I said adjunct. No, I did. Sorry. It's an adjunct. Oof. All right. This VP is an adjunct of this VP. So it's the daughter of a V bar and the sister of a V bar. On the other hand, questions about that? Okay. In this situation, where it's the man with a stick who's being hit by this animal, whatever he is, same thing as before, but we have N bars now, and V bars. With a stick here modifies the man, which means that we're going to put it in the NP. Where do we put it in the NP? Well, it's not a complement. I hope you can see that. So you can put adjunct material in between this head and this phrase. Right? The man sitting there, right? Or the man on my porch with a stick. The man in the room with a stick. And so on. So this phrase is not behaving like a complement, so we're not going to treat it like one. Complements are the daughters. Adjuncts are the daughters of N bar and the sisters of N bar, or daughters of X bar, sisters of X bar. In this case, it's N bar. Where's the complement? The answer is there's no complement. Right? So a man is a phrase that doesn't have a complement. And if you put a stick in his hand, he still doesn't need a complement. On the other hand, as before, a man with a stick, in this case, it's a constituent now, but it's still the complement of the verb, right? It's the object of the verb. Objects of verbs and prepositions are complements. How many V bars do we have? Answer, only one, because this VP doesn't have an adjunct anymore. So there were two V bars here, because with a stick was an adjunct of the verb phrase, so we needed to add another V bar so that we could add the adjunct that modified the verb. Now, we don't need an extra V bar, we need an extra N bar, because with a stick is now the adjunct of the NP, and we only need one V bar in this VP because there are no adjuncts in that phrase. The only adjunct here is an adjunct of the NP. Okay? Questions? Okay. So, when you draw trees, first
identify the categories of the words. I mean, look, this is one way of doing it. You can do this in any order you want to. If you want to work from top to bottom or bottom to top, it's up to you. I think most of you seem to like to work from bottom to top. So if you want to start at the bottom, you draw a tree by first identifying the categories of each lexical item. So what part of speech is each word? So a man with a stick is a D, man is an N, with is a P, is another D, stick is an N, and so on. While you do that, or after you do that, you determine which words or phrases form constituents. This should say form, sorry. Then you can apply the rules backward to build the tree. And so N is the daughter of an N bar. A P is the daughter of a P bar. A V is the daughter of a V bar, and so on. And when you have to attach modifiers or add modifiers to the tree, you have to think. You have to think especially about, is this phrase an adjunct or a complement? It makes a big difference. You have to test whether or not it behaves like a complement or it behaves like an adjunct. If it behaves like a complement, and only if it behaves like a complement, should it be the sister of a head. If it behaves like an adjunct, it has to be represented in the tree as an adjunct. Adjuncts are not sisters to heads. Adjuncts are sisters to X bar. Then, okay, start with the modifiers closest to the head, right? And then work your way outward. Then check your tree against the rules. Make sure that every complement is the sister of a head and every adjunct is not. Count. Do I have an N for every NP in my tree? Exactly one. If not, something must have gone wrong. Do I have, is the number of X bars in each tree equal to the number of adjuncts in that tree plus one? It should be. If it's less than that, something went wrong. The specifier rule and the complement rule will always apply. Even if you don't have a complement, you're still going to have a head. So the minimal X bar structure for any phrase will now look like this. So I think in the homework, wasn't there some simple tree like the VP arrive or a noun phrase like Bill? Right? Even these will need an X bar. So VP is the mother of V bar. V is the daughter of V bar. You can't get away from that. Same thing with APs. So in a noun phrase like the red book, right, this AP is going to have one A bar and of course exactly one A. Be careful about adjuncts. I already mentioned this before, right? So in a, oh, I should have made you draw this. In a noun phrase like hot tea, notice how many N bars are in this NP. It has to be that way, right? So this N bar, the AP hot is an adjunct. Hot, delicious tea, etc. You can put other phrases in between this phrase and this head, so we know it's an adjunct. Besides, complements in English generally go on the right of the head, not the left, so this wouldn't be a complement. It's an adjunct. It behaves like an adjunct. We want to draw a tree for it as an adjunct. That means the mother of the phrase must be an X bar, and the sister of the phrase has to be another X bar. In this particular case, it's N bar and N bar. For every adjunct in a tree, the number of X bars in that tree will be, the number of X bars in a tree will be equal to the number of adjuncts in a tree plus 1. How many adjuncts in this NP? 1. How many N bars do I have? The answer has to be 2. And so treat adjuncts like adjuncts. Don't forget. And let's see if you can draw a tree for. Took pictures of students from Canada and make sure that the tree reflects the natural meaning of this phrase. It means take pictures of Canadian students, not stand in Canada and take pictures of students. Go for it, VP.
Are we going to draw a tree on this little piece of paper? The only thing that is the daughter of a VP is a V-bar, unless it's a specifier, which would be news to me since we haven't even talked about what specifiers of VPs would look like. Tell me you're going to draw a VP with no V-bar. Hi. That's not right. Is that NP the daughter of a VP? My goodness, I never heard of that. Is that PP the daughter of a VP? Ruby's not writing anything. Pictures from Canada. And apparently you think the object of a verb is an adjunct? This is a complement of an adjunct. Second way. Oh, okay. Yeah, okay, so he stood in Canada and took pictures. Who's from Canada? Well, then make it look like that. He didn't take pictures from Canada. Okay, he did. I think not. Daughter of MP, sister of M-bar? No, it's a specifier. It's not a specifier. Thank you. Here's your tree. This is a compliment. It can be sister's good head. You don't need this one. What's from Canada? The pictures of the students? Oh my goodness. N but no NP. Okay, so took pictures of students from Canada. Took is a P, pictures is an M, up is a P, students is an M, from is a P, Canada is of course an M. You must know that students from Canada is a constituent, because I told you that the students are from Canada, right? So we're not talking about pictures from Canada. We're not talking about taking pictures from Canada, like being in Canada and taking pictures of the students wherever they might be, on the moon or something. This is a constituent, so we want to make sure that it is represented in the tree as a phrase. And of course, pictures of students from Canada is also a constituent, so it has to be in our tree.
What kind of a constituent is it? Okay, obviously an NP, but what kind of NP? Pictures of students from Canada. Is it an adjunct? Is it a complement? Those are really the only two choices. You could ask whether it's a specifier, but the only specifiers we've talked about are Ds, and it's definitely not a D. Pictures of students from Canada. Is it a complement or an adjunct? Well, I said before, objects of verbs and prepositions are complements. So you can take pictures of students from Canada with a camera. You can't take with a camera pictures of students from Canada. So it's going to be a complement of the verb, meaning it's going to be the sister to this V and the daughter of a V bar. So here it is. V bar is the mother of the head and the mother of a complement. Of course, pictures of students from Canada is an NP. So this VP doesn't have any adjuncts. This stuff here might have some adjuncts, right? But this phrase is a verb followed by a complement, and that's it. So we don't need any more than one V bar. Pictures of students from Canada is an NP. NPs are the mother of N bars and specifiers if there are any, but there are no specifiers in this phrase, so we don't need N bar to have any sisters. The head of this NP is pictures, obviously, of students from Canada modifies those pictures. Is of students from Canada an adjunct or a complement? It's a complement, right? Of phrases in English are just always going to be complements, almost always. I took pictures, well, let's see. Pictures of students from Canada, let's say, in a photo album is okay. Pictures in a photo album of students from Canada, that's pretty bad. All right, so this PP will be the daughter of N bar and the sister of N. Of students from Canada is a prepositional phrase. It's obvious that the head of that phrase is P. And objects of prepositions are complements. So this NP, students from Canada, will be the daughter of P bar and the sister of P. Now what we have to do is draw a tree for students from Canada. It's obviously an NP. NP is the mother of N bar. Now, we have to do the same thing we did before. We know that from Canada is a prepositional phrase that modifies students. But the important question is it an adjunct or a complement? Students with red hair from Canada, students of English from Canada. It's an adjunct. You can put things between this noun and this prepositional phrase, no problem. So it's definitely an adjunct. So the number of N bars in this NP will be equal to the number of adjuncts plus 1. The number of adjuncts is 1. Therefore the number of N bars will be 2. And this adjunct PP will be the daughter of an X bar and the sister of an X bar, as all adjuncts are. And then from Canada is easy. It's just a preposition and its object, meaning a preposition and its complement. And then Canada is just an NP, whereby just an NP, of course, I mean an NP, which is the mother of an N bar, which is the mother of the
Questions about this? Something to remember is if you're drawing something like this, you're definitely getting it wrong. VP is the mother of V bar, and, well, a specifier, if there is one, we'll see later that VPs can indeed have specifiers, but we haven't talked about that. So, the only daughter of a VP for now would be V bar. And in general, the only daughter of an XP will be X bar and a specifier. If there is one, the only ones we talked about are D's. So if you've got a daughter in your tree for the next homework or so, if you have a tree with a VP, the only daughter is going to be V bar. And if you're drawing a tree where the daughter of a, let's say, NP or a VP is some other NP or a PP, you certainly got it wrong. So, think about what phrases modify which other phrases. Notice that from Canada belongs to this NP whose head is students. That's exactly what we want because who's from Canada? What's from Canada? The students are from Canada. They're not pictures from Canada. I didn't take them from Canada. We're talking about Canadian students. So just like before, if the prepositional phrase like this one modifies this noun phrase, it has to be contained in it, and it has to be, this NP has to be the first phrase dominating that B. So think about, of course, the constituency relationships between the phrases, but now, additionally, you have to ask yourself each time, now that I know that this phrase modifies this one, how does it modify it? Is it a complement or an adjunct? And make sure you've represented them in the appropriate way. So for homework, you were supposed to do an example like this. If you have it with you, take it out and show me. If not, then do it now and do it quickly. Some man from Brazil bought a bottle of wine from the market. Okay, one little proviso here is that we need, in addition to our 3 rules of X-bar theory, some other rule that tells you what this guy is. So we can just say it's this for now. Of course, there are other complications, but you can just use this. So use this as a rule for a sentence. We're going to replace this very soon. And draw me a tree for this sentence. So the top of the tree will look like that. The rest of it will be done according to X-bar theory. You did the homework like good young people. Okay, I believe very good. Very good. Huh? Very good. Let's see. Good. have an N bar. From Brazil doesn't have a P bar. At the market doesn't have a P bar. The market doesn't have an N bar. This specifier, right? Order of NP. You've got to use an adjunct. It's not, this is a specifier. Nothing on this one yet. We need P bars here. This is a specifier. Order of NP. These as adjuncts, but they're specifiers according to what we've said. Whoa. A tree with 3 branches, no way. And these are daughters of NP. Very good. Good, except where's my P bar? A tree with 3 branches? Oh no. Okay, from Brazil is an adjunct. Daughter of X bar, sister of X bar. Good. Who's the man with the wine? Oh, I'm sorry. Just focus on okay, good. Good. Okay, so the man from Brazil bought a bottle of wine at the market. If you want to work bottom up, you can identify the categories of all these elements. Okay. And this other the are all D's. Man, Brazil, wine and market are N's. From, of, and at are P's. Bought, of course, is a V. The market is an MP. There's a determiner, which we're treating as our only specifiers at the moment. So, a specifier is the daughter of XP and the sister of X bar. And the head is the daughter of X bar. So this NP, the market, looks like this. The number of N bars in that NP is equal to the number of adjuncts, which is 0 plus 1 equals 1. Okay? Wine, same thing. It's an NP consisting of only an N. You need the N bar though. Brazil, same as wine. Just an NP consisting of an N. At the market,
as we mentioned, objects of verbs and prepositions are complements. So, at the market is a PP, whose head is P, and whose complement is the market, where complement is the daughter of the P bar and the sister of the head. Of wine, same thing. From Brazil, same thing. Now, bottle of wine is a head and its complement. English is easy because these of phrases are typically complements. So you can say, bottle of wine on the table, but you can't say bottle on the table of wine. So, complement means daughter of X bar, sister of X. A bottle of wine is just an NP with a specifier, right? An NP with a determiner. So, no adjuncts in a bottle of wine. It's a head, its complement, and a specifier, or a determiner. Okay, questions so far? Okay. Man from Brazil. Okay, from Brazil modifies man, that much you know. Is from Brazil an adjunct or a complement? We just had students from Canada, right? So man from Brazil is going to be pretty much the same thing. Man with a mustache from Brazil, man in my class from Brazil, and so on. You can put things between man and from Brazil. So you know that from Brazil is an adjunct. Adjuncts have to be sisters to X bars, meaning that we need another N bar in this tree, aside from the one that is the mother of the head, to be the mother of the adjunct. So, man has no complement, it's just a head, but its mother needs to be N bar, and it better not be the sister to an adjunct. Heads can't be sisters to adjuncts. Only complements can be sisters to adjuncts. Actually, only complements can be sisters to heads, excuse me. Okay, so the number of N bars in this tree is going to be equal to the number of adjuncts plus 1. The number of adjuncts is 1, so the number of N bars will be 2. So, the man from Brazil, excuse me, has 2 N bars. 1 for the head, 1 more for the adjunct. Bought a bottle of wine. Okay, that's a verb and its object. The objects of verbs are complements. So this bottle of wine will be the sister of the head V. So you can't say he bought at the market a bottle of wine. So this guy, a bottle of wine, is the sister to V. At the market, of course, modifies bought. Not the bottle, not the wine, but bought. And it is an adjunct. You know it's an adjunct. Right? It can't be anything other than an adjunct. It couldn't possibly be a complement because you already have a complement right there. Right? So it modifies the VP by way of an adjunct modifier. So it has to be the sister of V bar and the daughter of a V bar, which means this VP will have 2 V bars in it, not just 1. One for the head and its complement, another one for the adjunct. And then you're finished. Ivy. What's the matter? Question? Lacey, what's the question?
Other questions? Oh, boy. Okay. Let me just look at one more, I guess. What was this? The students of English with long hair, excuse me, the student of English with long hair is a friend of Patricia. Okay. If you wanted to start in a familiar way that did not involve X-bar theory, obviously this whole thing is a sentence. The subject is some MP, the student of student of English with long hair, is a friend of Patricia, is a VP. The main verb is, and the NP is a complement of the verb, okay? But this is the old way of doing it, and obviously abbreviating a great deal. If you wanted to break it down and abbreviate a bit less, you know that of English with long hair and are all part of this NP that modify the head students. A friend of Patricia is a determiner, a noun, and obviously a PP modifier. We haven't even done X-bar yet. Of English and with long hair are obviously PPs. The first one consists of a P followed by an NP, as does the second one. With long hair has an NP that's modified by an AP. And then of Patricia is a PP followed by a P followed by an NP. Now, how do I turn this into an X-bar tree? The answer is, I make sure that every phrase has at least one X-bar, and that the number of X-bars in each phrase is equal to the number of adjuncts in that phrase plus one. How many adjuncts are in the phrase a friend of Patricia, the noun phrase, this guy here? How many adjuncts are in that phrase? Karen, how many adjuncts are in this phrase? Which one? None. Okay. A friend of Patricia with long hair. Okay. A friend with long hair of Patricia. Okay. You can't separate this phrase from the head because it's a complement. And as I mentioned before, if you have a PP in English that starts with of, you can bet it's a complement. If not, you can bet it's an adjunct. So, how many adjuncts? So this NP is going to have how many N bars? Just one. There's no adjunct. Right? Specifier, head, complement, not adjunct. So you don't need an extra N bar. Patricia has how many N bars? Just one. There's no complement, right? What about the student of English with long hair? We know that that's an NP. How many adjuncts are there? Is with long hair a complement or an adjunct? Adjunct. Is of English a complement or an adjunct? It's a complement. So, number of adjuncts is 1. Number of N bars here is going to have to be 2.
One for the head and the complement, the other one for the adjunct. Long hair. How many N bars will there be in that NP? There will be how many? Why 2? Okay, one is for the head, the other one for the adjunct. Long is an adjunct. It modifies hair. It's obviously not a complement. Right? So, there you go. These specifiers are daughters of XP and sisters of X bar. Daughter of NP, sister of N bar. How many N bars do we need in this NP? Well, the number of N bars or the number of X bars is equal to the number of adjuncts in the phrase plus 1. There's an adjunct in this phrase. Adjuncts are the daughters of N bar and sisters of N bar, or daughters of X bar, sisters of X bar. Student of English is a head and its complement. Complements are the daughters of X bar and the sisters of X. This prepositional phrase consists of a head and its complement. Here's long hair. Long is an AP adjunct. Adjuncts are the sisters of X bar and the daughters of X bar. So this NP has, as we stated, 2 N bars in it, not just 1. The AP long is easy. Of Patricia is easy. We said a friend of Patricia has no adjuncts, so there's only 1 N bar there. And is a friend of Patricia is a VP consisting of a verb and its complement. So there's only 1 V bar here. Okay. Questions about this? Anybody want to take a picture? The homework for, please do it by next week. And be careful about adjuncts and complements. You need to represent them correctly in the tree. Don't just start drawing what you hear. Right? Think about what modifies what, and think about whether it's a complement or an adjunct. And be sure, if you have anything that's the daughter of an NP, it better be just a specifier, in other words, a determinant. And if something is the daughter of a VP, it better just be a V bar. Same thing with PP and so on, right? The only daughters of AP, PP, and VP in these trees that you're drawing now will be V bar, P bar, and A bar, respectively. Okay? All right, if you get stuck, let me know. Have fun. See you next week.